We're going to talk about z-scores a little bit here. The z-score is the number of standard deviations above or below the mean. So the z-score of 85 is -1. That just indicates that this particular IQ score is 1 standard deviation below the mean. Write the z-score of each IQ score. So for 55, that is 3 standard deviations below the mean, so -3. 115 is above average, so that would be a +1. You do not have to write a plus on the 1, I just did that to emphasize it. 130 would be z equals 2, and 145 would be z equals 3. So you're just saying how far above or below average it is in terms of the standard deviations. Now there's a formula for the z-score. Z is equal to x minus mu divided by sigma. So if we follow that formula and we plug in 130 for x, we plug in 100 for mu, and then we subtract, we get 30, we divide by 15, and we get z equals 2. So that gives us the z-score, especially if it was a value that wasn't one of these incremental values. So let's follow that process again to find the z-score for x equals 80. Z would be 80 minus 100 divided by 15. So that's going to be -20 divided by 15. -20 divided by 15. Whoops. Enter. And I'm just going to point out to you that this negative button here is different than the minus button. If you turn the minus button, it thinks that you want to do the previous answer minus something. So don't use that minus button. Use this minus button for a negative number. So this is saying that z is equal to -1.33. So it's more than 1 standard deviation below the mean. And that just tells me that we're right about there, so I can see that. Oh, let me go back to this slide. This is a different formula, and you may see this from time to time where you're actually starting with a z-score and trying to figure out what x is. If x is 130, it's the 100 plus 2 times 15, so that's your z-score. What would be the x value for z equals -2.5? Well, I can tell by looking at my graph that we're going to end up right around there. So I could guesstimate the value, but I could also just use this formula. So x is equal to 100 plus -2.5 times 15. So what is -2.5 times 15? That's -37.5. So I just need to do 100 minus that, minus 37.5, and I get 62.5. Does that look like a reasonable answer? Yeah. So an IQ score of 62.5 is 2.5 standard deviations below the mean. By the way, let me just go on a tangent here and say that I'm not sure what the status is on IQ scores, but I never have had one. And I sort of resent the idea that your intelligence could be measured by a single number. I think there are so many different ways to be smart. You could be socially intelligent and super clumsy, or you could be incredibly graceful and maybe not so good at reading. or you could be good at reading and art and incredibly socially gifted. So I just think of intelligence as being really multifaceted. And when people are bad at math, I don't assume that they're dumb. I just assume that their gifts lie in other areas and that all my students are smart in one way or another. I'm showing you here that there are z-scores instead of x values on the x-axis. So anybody who is exactly average has a z-score of 0. Or somebody way over here has a z-score of 3. The standard normal distribution has a mean of 0 and a standard deviation of 1. So this is going to come back later. These are the z-scores, and they are distributed normally, again with a mean of 0 and a standard deviation of 1. And any normal distribution can be standardized, so you'll see us doing that, and we just convert the x values to z-scores. Let's use normal CDF on the calculator. So second distribution, normal CDF, and do we agree that the probability that z is between -1 and 0 is 0.341? So it will be normal CDF. I want to go from -1 to 0. Those are my lower and upper bounds. And then I give lower, upper. And then I give the mu and the sigma of the distribution, which happen to be 0 and 1. And I'm expecting this to be 0.341 or something similar. So let's see. -1, enter, 0, enter, 0, enter, 1, enter. And yeah, maybe one more decimal place would be good if I'm doing 4 decimal places, or I could just say 34%. And I think we've touched on this as well. The probability that x is bigger than this specific x, like if I was trying to find the white area, it would be 1 minus the purple area. And by white area, I mean this white area, not the other part of it. Yeah, so they add up to 100%. So if you've got like 0.25 over here, then you automatically know that 1 minus 0.25 is going to be 0.75 over here. And with that, I'm going to jump over to our next video.